Okay, hey y'all, just got to my office. So I have this really bad characteristic flaw where I can't really let things go, and I completely hate feeling as if like I didn't make sense or I got too confusing or I let somebody down. So this is a video of exponent rules, or also known as the laws of exponents. Okay, so what we have is a too thick of a marker. Oh, just let's restart everything. Where am I? Oh, you're killing me, Smalls. Okay, so it's still sharing. And what I want is this. Okay, I don't know how big this is going to write. So what we have is a product rule, product meaning multiplication. The product rule states that if you have a variable, I'm going to go ahead, I'm going to use A's, okay? Say we have a variable multiplied by another variable. Okay, now the thing is, what they're going to do is in the exponents, they're actually going to have the fact that there may be an exponent attached to our variable. They use n and m. It doesn't mean they have to be different. That's literally just notation. We couldn't use n and n because then that would be implying that you could only apply the product rule if the exponents match, and that is not true. Whenever you add and subtract, that's that rule. That is true for that rule. But when you multiply, the only rule that you need to apply this rule is the fact that you have the same variables. So if you have the same variables and both of them are being raised to whatever exponent they're being raised to, what you do is you keep and you add. An example of this would be if we have a to the 8th power times a to the 6th power. You keep and you add, which is 14. Okay. Don't confuse this with if you have an a to the 8th power times I wanted to do a y, so I used x and y, and you have a b squared. You can't actually apply the rule where you add the exponents, but you do have the ability to multiply them, but you see how they just stay separate, right? And that's because they're not the exact same variable. When you have the exact same variable, an a and an a, what you do is you add the exponents. That is the product rule. Okay, so there is another rule. I'm just going to clear the whole canvas. There is another rule, which is called the quotient rule. So quotient, that is actually the answer to a division problem. So when you see quotient rule, it means that what we're doing here is we're dividing. And this says that if you have a variable, any variable, raised to a power, any power, and you divide it by the same variable, also raised to any power. That's why we use n and m, just to differentiate between the fact that they may or they may not have the same power, but it really doesn't matter what the power is. The only thing that matters is that they're the same variable. What you do is you keep and you subtract. Okay, so an example of this would be is if we have a to the 14th power over a to the 12th power. Ooh, keep and subtract, and we get a squared. Okay. There's another rule called the power rule. This is saying that we're looking and dealing with powers, which is another way to say exponent. But if you have a variable raised to a power and then it's raised to another power, what you do, power to a power, you multiply your powers. An example of that would be a squared would actually be a squared, and then you do your times 2 and you would get a to the 4th. Okay, now we have a power of a product rule. So we have a power of a product rule. I'll record a video without the screen messing up and me being in a hurry to go to another class for like my intermediate algebra class. And I'll actually like have more examples and actually applying the rules, and I'll post that and share with y'all, okay? So the power of a product rule states that if you have, okay, so power of a product rule. Product rule means multiplication, right? So say you have these two variables being multiplied, and then it's raised, so this is the product, and then it's going to be raised to a power. And we raise those two variables to a power. The power of a product rule states that both of the variables will be raised to that power. An example of that would be if we have, excuse me, a times b raised to the third power, that is actually a cubed times b cubed. And that very first power, we can't do anything with this because those aren't the same variables. If they were, we could apply the product rule because the same variables would be multiplying. And it does not matter. I don't want to use the fact that they both have a threes, meaning, oh, now we can multiply them. It doesn't matter what their exponents are. As long as they're the same variables, you keep and you add. Okay, so we also have the power of a fraction rule. The power of a fraction rule just states that if we have two variables in fraction form raised to a power, they both get raised to that power. Then we have a zero exponent rule, which states that any single thing in the world raised to the zero power will give you 1. Okay? And then we have a negative exponent rule. Okay, so if you ever have a variable raised to a negative power, what you do is you take the reciprocal and the power becomes positive. And hopefully y'all notice that this equal sign, that means equivalence, right? So if we have something in the denominator, we can rewrite it like this. The number 1 could be rewritten as a variable raised to the 0 power. If we have the form on the right, we have the ability to write it like that. Every single rule. That equal sign means it goes both ways. And then lastly, we have a fractional exponent rule. Not really lastly, because there's a lot more, but these are the only ones that I could see y'all needing. If we have a power raised to an exponent, if we have a power raised to an exponent that's in fraction form, it actually can be written with your denominator as your root and your numerator as your exponent. I don't know how to make that go away, y'all. Okay. And again, if you have it this way, you can also write it this way. So an example of this would be like a to the 1/3 could actually be written, denominator's your root, your 1's your exponent. A to the 3/5, denominator root, numerator exponent. A to the -6th, 1 to the a to the 6th. Usually this is the more proper way to write it because you never want negative exponents. Fifth, b to the 5th. Okay, y'all. So hopefully that helps somewhat. I know that our main issue was the fact that I couldn't on the spot right then and there come up with a decent example as far as multiplying variables. Let me do just one example right here. If we have x squared times 2x cubed plus 3xy minus 6y. It being right next to the parentheses would imply multiplication, and then we're going to do our multiplication. We're going to distribute that 1 in front of the x squared. We do 1 times 2 is 2. Okay, signs are the same, so it's positive, and then now you look at your variables. The product rule tells me that when you multiply variables, you keep and you add. Now we do this right here. 1 times 3 is 3. Signs are the same, so it's positive. Looking at my x terms, product rule tells me that if you have the same variable, what you do is you keep and you add. Don't forget your y. It didn't change, but there's not another y to multiply it with and like to cause the exponent to get larger. Then lastly, we have our x squared times a negative 6x. 6 times 1 is 6. Signs are different, so it's negative. X squared times y is just x squared y. Okay, y'all, so hopefully that makes a little bit of sense. And again, sorry. Thank y'all. Bye.